All right. Hey, Simon. Good to have you here. Thanks for
Hi,
joining
Pete.
us.
Great. Thanks for inviting me.
Hey, I figured we'd start off by just you could do a brief intro and tell us a little bit about your role at Meta and some of the stuff you've been working on.
Yeah, sure. So I'm Simon Marlow. So I've been at Meta for just about 10 years, actually. I'm currently working on what we call the code search and indexing team at Meta. Our team deals with kind of systems and tools and so on that help developers find code and navigate code. And one of the main things we do is we deal with a system called Gleam, which is doing code indexing. So indexing information about all the code bases that we have in various different languages.
And what languages are the big ones for you guys?
Well, we have an awful lot of Hack, which is our version of PHP. We have lots of C++, Python, Flow, various other languages. I mean, I suppose those are the main ones. But you know, there's always a long tail of languages as well in that we want to handle. There's Objective-C, there's Java, of course. We've got a fair amount of Java, and then there are a long tail of languages beyond that.
And are you supporting a repo, a mono repo, or lots and lots of little repos, or a hybrid?
Well, we're moving more and more towards a mono repo. I think, we've talked a lot in the past externally about how we think a mono repo is a great way to manage your code, especially a large company like we have. And yeah, so we have a lot of our code in a mono repo internally, and that presents lots of challenges, I think, for doing code indexing and code intelligence. It presents as many challenges as problems it solves in some sense, because you have a huge scale of languages and the amount of code that you need to index together to provide a consistent view for developers across the entire repo.
Well, let's talk about that. So I think that a lot of our listeners may not be super familiar with the kind of tooling that you're building, because I don't think that it exists at a lot of other companies, even though there's probably a need for it. So why don't you tell me a little bit about, broadly, how do you define code intelligence and what does it mean at Meta? And, what are your sort of ambitions and the problem that you're solving here?
Yeah, so a few years ago, we looked at the problem and tried to find a general solution to a number of different use cases that we saw in this space. And I mean, the obvious one is code navigation. That's where you typically start from, is the idea that you want to be able to give developers the ability to go from some source code where there's some symbols to click on a symbol and go to its definition. That's one of the basic things that you want to do. But then you also want to find out for a given definition, what are all the places in the code base that reference this definition, that call this function or whatever. And that's a good starting point. But then there are a number of use cases that kind of follow on from that. So you've got things like code documentation, where you'd like to be able to, from the source code, generate some nice pages of documentation that are hyperlinked, that the developers can navigate around and give a nice sort of browsable way to view APIs and to navigate APIs separately from the source code. So that's one use case. And then you probably would like to be able to ask questions in general about information about your source code. So you might be able to construct queries that let you extract information about the code. Find me all the ancestors of this class, or find me all the functions that this function calls transitively, or look at my build graph and find all the executables that reference this library. Or there's a long list of questions that you would like to ask that involve information that's not directly manifest in the source code or in the build system.
Okay, but I mean, like, when I hear that, just kind of trying to channel, developers who haven't worked at Google or Facebook or Meta, isn't that an IDE? I mean, doesn't an IDE do everything that you just described?
I mean, it does some of those things for sure, right? So in your IDE, you can navigate around the code. You can see metadata, you can see outlines, and you have a number of features for sort of navigating code using the kind of data that we collect through indexing. But I mean, IDE doesn't typically give you easy access to analysis that does dead code analysis, for example, that finds all the functions in your code base that aren't referenced from somewhere. So I think it goes a long way beyond what you can typically do in an IDE. An IDE is one use case for some of this information, but often you want to collect a lot more information than the IDE uses, and there are use cases beyond what the IDE is providing. So I think it's part of really the whole ecosystem of tools that you want to give developers, and a lot of these tools need metadata about the source code. They need semantic information about the source code. And you need a system underlying that collects the information and provides you with a convenient way and a powerful way to query the information that you collected from the source code. And that leads to a number of different tools, of which the IDE is one, I think.
So isn't it also the case that IDEs don't really scale up to Meta's code base size?
Yeah, I mean, this is one of the big problems that we're trying to solve, especially in a mono repo. So, I mean, you're probably familiar with working in an IDE on a fairly small code base where you open it and your IDE can index all your code on the fly on your local machine. But as soon as you have a huge stack or a mono repo of code where you can't realistically index the entire thing on one machine on your local laptop or whatever, or maybe even working in an open source world where you're working on one project and you're on top of a huge stack of libraries and systems that you use, and you'd really like to be able to navigate around all of that stuff with the full fidelity of information that you get for the project that you're working on. So one of the scaling problems that we're trying to solve is giving developers the full resolution of data about their project they're working on, but also across the entire repo, and as far as possible giving them information about all of the other projects and all the other libraries and things they might be depending on throughout the mono repo, and providing a seamless experience when they navigate outside the project. So that's one of the problems.
Yeah, so we built back when I was at Google, we built something like this as well, and we ran into the same problems, right? Which is fundamentally that you want all of your IDE capabilities at scale, and they just the IDEs are very project centric. They're also fundamentally not scalable. And the thing that we noticed was that people kept coming in and they couldn't find their way around the code base, and so it was a difficult hump, I think, for people to get over, like, because it sure seemed like an IDE. But one of the things that I really loved about it, and you sort of hinted at this when you were talking about the dependency graph and the build graph, is that these code intelligence platforms that you've built at Meta and that we built at Google, which can power all sorts of tools. We'll talk about that in a bit. But one of the really cool use cases that it could do is it could tell you who you're going to break if you change something, right? Like, in other words, who depends on you, which an IDE won't do. An IDE tells you who you depend on, so that if one of them changes, your project will break appropriately and the IDE will complain about it, right? But if you're a library maintainer, how amazing is it to be able to go and say, I'm proposing a change to this library, and I want to know everybody across the entire company that's going to break because of it. And I want to be able to automatically manage pull requests that go out to these team members and maybe even suggest fixes for them. Yeah, when I do like a big mass refactoring. Do you guys have something like that at Facebook?
Yeah, absolutely. I mean, this comes up in a couple of different ways. So one is the thing I already mentioned, where you're finding all the references for a symbol, going from a definition to all the places in the code base that reference it. And you can do that transitively. So you could find all of the transitive references of something. So that's at the sort of the code entity level, and then there's the same thing that comes up at the maybe the target level or build rule level. So through your build system, finding all of the entities in the build system that might reference something. Yeah, so this is something that we handle in a kind of general way in Glean. The idea is that when you're collecting information about your language or your build system, you encode in Glean the facts that point from the usage to the definition of something. And then Glean can automatically derive the arrows in the opposite direction. And we call this derivation. So it happens in a sort of automatic step after you've collected all the information. So it derives all the arrows in the opposite direction. And then you can follow these arrows. So you have information about the definition going to all of the uses of it and so on. And then you can follow those arrows recursively. So yeah, I mean, this is definitely something you get as an added value from having a system that's pre-computing or pre-collecting all of the metadata, and then you can derive additional data on top of that.
So you're getting all this information from basically compilers, right? Or from systems that are very compiler-like. I'm sure Hack and Flow both have, type checkers and things like that, right?
Yep.
So you have to run these compilers in a special mode. You're doing a special build of the code, right? That's how we did it at Google. We instrumented the build system to sort of not generate what you normally generate with your build. You don't generate the binaries and artifacts and jars or whatever. You're generating index artifacts as part of your build, right? You guys do it that way as well, yeah?
So it depends very much on the language. Each language or each compiler does this in a different way. And we haven't built in any particular mechanism for doing this in Glean. It's very much up to what we call the indexer. The indexer is the thing that looks at the source code and generates the facts, which is what we call them. The facts is the data that goes into Glean. So you build one of these for each of the languages that you want to index. And for example, for C++, we're just using the Clang library as a backend, as a way to process the source code and give us the abstract syntax tree, the internal representation of the code that we can then process and walk over it and generate the data for Glean. That's for C++. And then for Python, there's a similar sort of thing called libcst that we use for doing that. And I think for Java, we have a compiler plugin that can do a similar sort of thing at compile time for Java. But whether you do it at compile time or by invoking a library or by a completely standalone tool that just processes the source code using a different library, it depends entirely on how you want to build these things. And we don't mandate any particular way of doing that.
Yeah, it's interesting because you're doing the same work for every programming language, right? Effectively, you need to find the cross references and the symbol declarations and work your way through the call graph and all the other artifacts. Those things are all language independent by and large, right? So you're coming up with a language neutral representation.
Well, actually, so in Glean we don't have a language neutral representation, at least not at first for each language. This is one of the design choices that we made in Glean, is that we think each language may have language specific use cases as well as language neutral use cases, and we want to support both of those things. The language neutral use cases are things like code navigation, the typical use case where you want to navigate around symbol definitions. But there are lots of language specific use cases as well. For example, in C++, we're doing we have an analysis to detect dead include statements, for example, and that relies very specifically on particular semantic aspects of the way C++ works. It depends on using declarations and weird things to do with how namespacing works and stuff like that. So we don't mandate any particular language neutral representation for the data we collect. Each language can collect data that's specific to the language, and then we abstract over that. So for each language, there's a mapping between the language specific data we collect and a language neutral representation of that. And again, that's a form of derivation. So it happens that we derive these additional facts from the original facts that we collected about the source code. That happens in a general way. You program all this in the what we call the schema layer in Glean. And for each language, you just do that separately, so we can provide language neutral information for all of the different languages that we support.
So you've got this team that's putting this in a tremendous amount of work to build what could be argued to be IDE-like functions and a set of even richer functions like static analysis. But for all employees of Meta, And it's a lot of work, right? It's ongoing maintenance because you have to maintain these indexers, which are very bespoke and very language specific, and they shovel that data from your nightly build or however often you're doing it into your Glean database. Well, do you ever feel like somebody ought to standardize that at some point?
Yeah, I mean, that's a really good question. So, I mean, just internally, the way we're trying to scale this is by not doing all the work ourselves as far as possible. We try to make it as platform-like as we can. So we provide a platform that people can build their own indexes. Other language teams throughout the company can build their own indexes on top of our platform.
Has that been
But
successful?
and it's had some success. Let's say that it's had some success. Definitely, the core languages we're maintaining within our own team, because those tend to be the languages that we want to focus most effort on a continuous basis. And C++ is very much the one that tends to require the most effort. Let's say it's the most
No,
complex of all of the use cases.
that was absolutely true at Google as well, right?
Yeah, yeah.
The Kai team there told me recently that something like 50% of the artifacts in their schema are just there to support C++. So it's just this monster.
Right. Our C++ schema is definitely the biggest and most complex of all of the schemas. But I mean, for this long tail of languages, we often don't have the effort available. I think going back to what you said previously about needing some kind of standardization, I think that's absolutely true. We would very much like to be able to piggyback off other people's efforts in building indexes and as far as possible, and having some kind of standard format for that would I think be a great improvement over the current situation.
Yeah, I think so. So why don't we talk a little bit about some of the really, really cool use cases that you're enabling or that you can enable with your code intelligence platform that people might not be aware of?
Well, so I mentioned code documentation earlier on. That's one that we're quite actively working on at the moment. I mean, you've probably seen things like Doxygen and so on. Each language has their own sort of solution for doing this sort of thing. But there isn't really a language independent way of doing it. And that's something that we're trying to build internally, is a language independent way to do that. And it involves having indexes that collect enough information and then plumbing that through our language independent layer through to there's a sort of middleware service that we call Glass that takes all of this data and exposes it in a much simpler way to clients. So the Glass layer,
I just got to say, man, I am so jealous. I am so jealous that you guys did this because we tried at Google. I had engineers on it. We were passionate about it, right? The universal doc system tied with the code, because your doc comments, they're part of your code. I mean, that becomes even clearer when you start training generative models, right?
Yeah.
And we never got it off the ground. We implemented like a V1 of it, and then we just couldn't. It's just a lot of work.
It is a lot of work. Getting all the details right is a tremendous amount of work, and that's very easy to underestimate. Making sure that you've got all of your function modifiers right for all of the different languages that you support, and there's a huge amount of detail that you have to do, and the way that we found that to do this that works is by working very closely with people who are intimately familiar with those languages and getting them to give us all the feedback about the things that are wrong, so that we can just keep fixing it until it's good enough. And we have to do that for each of the languages. So it is a huge amount of work, but it's so worthwhile. I think having access to online documentation that's accurate all of the time for your code base, and you can link to it from everywhere. So you quite often have wiki pages where you want to link directly to the documentation for some code, and just being able to have a well-defined URL for that remains correct all of the time is really great.
Yeah, and also that kind of information is really, really valuable for training models and as context for feeding LLMs. Speaking of which, let's talk a little bit. Let's close actually with how you think the future is unfolding for code intelligence. How do you see the intersection with AI?
Yeah, well, I mean, obviously this is super interesting at the moment. AI has the potential to be a massive improvement for productivity for developers. But of course, there's a lot of challenges there as well. I mean, if you suddenly have a lot of AI generated code, is that just going to make it much easier to write all of the boilerplate? And then are we going to end up with a massive amount of boilerplate code that we didn't really want?
I mean, that's exactly what happened with IDEs in the mid
Right.
90s. Right? I remember when IDEs came out and they were really good at generating boilerplate, and they generated so much that you needed IDEs to manage all the code they were generating. And I do actually think that we're in an analogous situation today. The AIs are going to make us so much more productive that you're going to need AI to manage the code that's getting generated.
Right.
But we've already shown with IDEs that that was a net win. Yeah. So I'm not too worried about it. What about
Yeah,
you?
yeah, maybe. I mean, I really want AI to tell me how to make a better API that doesn't need all of the boilerplate usage at all the usage sites. So
Oh
that
my
would be
goodness. Well, so that right there, I believe that might be the intersection that we're that's the holy grail, right? If we can find a way to get that part of our code graph into the get those facts right into the AI, then it can actually I think it can be reasonably expected to tell you how to make a great API, for example.
yeah, I think that would be amazing. But I think in the short term that there's some pretty clear benefits that we can get by using all of the data that we collect in these code indexing systems and using that as part of the training model for these models, and to give you more than you get just by looking at the text of the source code. I think there's
For
a
sure.
richness of data available that we're not really exploiting at the moment.
Yeah, I 100% agree. Well, hey Simon, it has been an absolute pleasure having you on the show today, and always awesome to compare notes. I think you and I might want to put our heads together and maybe look into this whole standardization thing. There might be some legs there.
Sounds great. Good to talk to you, Steve.
All right, thanks, Simon. Simon, take care.